This is an example of a variable width histogram. You can see by looking across the bottom of the histogram that these bars have got different widths. That's because they've been grouped into intervals with different start and end points. And that's particularly useful when the data is close together and in different intervals, and you need to focus a little bit on those bars rather than look at the end. There's not much going on the end, so we'll give it all, lump it together in one bar. Anyway, this is a histogram, and on a histogram it's the area of the bars which tells us the frequency. Let's look at the frequency of this first bar as an example. It goes from 0 to 10, and the frequency density, which is the distance up the y-axis, the frequency density is here 0.2, 0.4. 0.4 by 10 is 4. So the frequency in this area is 4 people. The next one goes from 10 to 15, and this has got 1.4 people in it, and 1.4 times the interval width from 10 to 15 is 5. 5 times 1.4 is 7. You get the idea. But how did we get that data in there in the first place? Well, it began life in Excel looking like this. Here we are. Smarties and chopsticks. This is the Excel data. This is just ordinary data we just put in. Just have a quick look at this table before we transfer it over. In this experiment, people were asked to transfer 10 Smarties from one bowl into another using a pair of chopsticks, and we measured how long it took them in seconds. So from 0 to 10 seconds, 4 people managed to do that, and from 10 to 15 seconds again, 7 people, and so on. But why did I put these in brackets? Let's have a think about that. Because this is continuous data, and there's no such thing, in fact, as 10 seconds exactly on the button, as it were. Either it's slightly less or it's slightly more. If it's ever so slightly more, we call it 10 and put it in the 10 to 15 box. If it's ever so slightly less, we put it in the 0 to up to 10 row here. If it's 10 on the dot, as if that's ever likely to happen, we'd put it in the second row, obviously. So 0 up to everything, but not quite 10. That's why the 10 is in brackets. 4 people. From 10 upwards, up to 15, but not quite there. 7, and so on. The continuous data, no gaps, no overlaps, very well defined groups. If we didn't have the brackets, 10 would be in both of those rows, and that wouldn't be satisfactory. So 0 up to 10, 10 up to 15, and so on. So here's the data. I'm going to need to use these, which are my definitions of the class intervals, and the frequencies are here. Let's see what Autograph requires to put that in. We go to Autograph, and we need to select a new 1D page. So let's choose that, and it gives us the blank screen that we expect, and we're going to put the data in. Data, we've grouped the data, so we want to enter grouped data in this case. Here we go, select, enter, grouped data. We need to type in here Smarties and chopsticks, which we'll do, and we need to enter the left limits. Let's just delete what we got there. Have a look again at the left limits. Those were these numbers, 0, 10, 15, and so on. And we'll include the last limit as well, 60. So we need to type in those numbers. Let's go back to Autograph and type them in. 0, 10, 15, 18, 20, 30. And I said we have to put the last one in as well, so we'll put 60. That's our entered manually. We're also going to enter the frequencies manually as well. Where do they come from? Go back to Excel. That's these numbers, 4, 7, 8, and so on. Put those numbers in now. 4, 7, 8, 10, 2, and 1. Now we've got to decide one more question. Is this continuous or discrete data? Well, if we were counting the Smarties that they managed in, say, a minute, that would be discrete data. As we're measuring a time, we're dealing with continuous data, so we'll leave the radio button checked there. That's everything we need. We'll press OK. Oh, but where's the histogram gone? It hasn't drawn one. It hasn't drawn one because we haven't asked for one. So let's ask it for one. Histogram, please, Mr. Autograph. Up there in orange, we click on here, and the histogram will appear. Well, look at this. It's asking us what sort of histogram now. Do we want frequency density or frequency showing? We need frequency density because this is the correct way to draw the histogram using areas. We're going to plot the bars upwards. Yes, draw the histogram please, rather than a frequency polygon, say. And we're going to fill them in with a color, so we'll get solid colors, and it will look like that. How good is that? If you're not sure about the scale it's using, check this box. Is it auto scale? And if it needs to be changed, that will change it. But it seems happy with that. That is effectively the end of the histogram, but we can do so much more. So let's have a look at a couple of other things that we can do. We've got some useful buttons here with the statistics box, table of statistics, and so on. What's in the table of statistics at the moment? Well, let's look at the results box. At the moment, it's empty. Let's look at the table of statistics and see what that does. Table of statistics puts some things in the results box. That is the same results box we had earlier, but now it's got all these things in. Let's just drag it off to the side to explore. What's it saying? Oh, look at this. This is fantastic. Bit wider. This is all the data we put in, but set out in a form of a table. So it's worked out the mid-interval values for our data, it's done cumulative frequencies, it's calculated frequency density for us in the way that it's plotted. We've got all the calculations on the data itself using these mid-interval values, so we've got standard deviation and mean and all the rest of it. All very exciting stuff. We can use that a great deal. So let's just pull that back again, pull that off to the side. And what was this other one? Table of statistics. Let's have a look at that. Same thing. Sorry, I meant to do view statistics box. There it is. The view statistics box. Have a look at that. And this statistics box is the data itself. Now it's unknown here because the raw data is not given. We only gave it group data, so that's why all those are sensibly unknown. Group data, here we are, it's given us total frequency, interquartile ranges, and so on. So that's all good. If we want to put that in there as well, we just transfer it over, and in it goes. So this is a very useful box here in the results box. Think of the results box as a sort of notepad of all your ideas as you go in, and you can just fill it with data. If you need to remove things, let's take that out as that was repeated. We'll highlight it and press delete. There it is, it's gone. So this is exactly what we're going to be pasting into our project when we edit it in Word or whatever we want to do. As these are unknown, it doesn't seem sensible to keep those in, so I'm going to take those out as well. Highlight and delete. So here's all the summary of all my data. I've got my histogram, so I can copy, paste that into Word, and if I pull this to the side, give it a bit more space, I can do a print screen. There's my histogram. We could give it a title. Let's give it a text box, type in the title of our project, choose a style. I quite like ice blue, and if we choose ice blue, there it comes up, ice blue, Smarties and chopsticks. There's our histogram. One other thing for clever A-star people, this is brilliant. You won't believe what you can do with this. The probability by area is legendary. Watch what you can do. Click on that. It's already got the histogram, so it's lit up. And press OK. That will be enough for now. Now look at this. You see this has appeared down here, these yellows. You've got handles here. You can move these handles. Now I want you to pay attention to what happens on the writing on the bottom as I move these handles around. Have a look. I'm going to pull this one up to, say, 20. Roughly 20. How well am I doing? Well, I've got 19.9. That's pretty good. And move this one, say, to 10 or so. Lower, 9.974. That's pretty good. Right, well, what it's doing is saying how many people are in that region. Look at this. Between 9.974 seconds and 19.9 seconds, I've got 24.53 people, or a probability of being in there of 0.7664. We can say then, if you like, 76.6 or 77% of our people in our survey were between 9.97 seconds and 19.9. So we can say between 10 and 20 seconds, 77% of our students had their times for moving these Smarties by chopsticks. Very, very powerful. You can move these around, get different data, all very exciting. And if you want to take it off, just press delete, and off it goes. So very clever stuff. You pop it all in your project and get huge marks for some very easy work indeed. Have fun with that.